welcome everyone to nutrInsights, our expert interview series from nutriNews International, where we explore forward-thinking perspectives in animal nutrition and production. My name is Alvaro Guzman. I am part of the editorial staff here at nutriNews International, and today it's a pleasure to be joined by Dr. Luis Fernando Romero Millan, who is an animal scientist currently based in Portugal. And so, Luis, thank you very much for joining us today.
Thank you for the invitation. It's a pleasure.
That's great. So to begin, could you share a little bit with us about your professional background and what has led you to the current position you have right now, to have an idea of who you are?
Yes, of course. So my current position is I'm the founder and the managing director of Biofractal. I will tell you more about the company later. But basically, I'm an animal scientist originally from Colombia. I work in the poultry industry at the beginning of my career, managing farms and hatchery plants in poultry operations. Then I did a PhD in Canada, in Edmonton, Alberta, also related to animal nutrition, specifically the nutrition of broiler breeders and broilers, and how efficiency in the breeders affects efficiency in the broilers. After that, I went to England. I worked for many years for a company called Danisco Animal Nutrition. Now they are part of IFF. And I was leading the innovation team for the company for animal nutrition and health, basically developing enzymes, probiotics. Some of the enzymes that we developed are leaders at the moment in the market, something like phytase, protease, etc. Then I worked for a few years in DSM in Switzerland. I was managing the innovation portfolio for animal nutrition and health for the company, and that is a broader portfolio, includes things like vitamins, but also gut health additives, enzymes, etc. And in 2020, I left and started the company. We are a small team. We have 6 people. And basically what we do is we work with companies that are developing and commercializing feed additives. We help them to understand mode of action of those additives inside the animals and to make the connection of what we find with performance, so they can understand how to optimize the product they are developing. They can understand which products were better than others, if they want to make a selection of products, and they can use the information that we produce also to position the products in the market.
Okay, that's great. Thank you for walking us through that very interesting career path. And that leads the way into what we want to talk about today regarding feed additives. So let's get to it. So in terms of feed additives, we often evaluate these in controlled environments, but we well know that commercial production settings are far more complex. So in that sense, how should the mode of action of a feed additive be reconsidered when we transition from the lab to real-world scenarios and real-world systems?
Yeah, basically, the mode of action of feed additives needs to be taken into account. There's the entire system the animals are in. And that means that mode of action of a feed additive is always context dependent. So it depends on what's happening in the animal environment, including the temperature, the social interaction it has, the diet, the challenges it has. Normally, what has happened is like the mode of action of feed additives is defined very specifically for what you can demonstrate in vitro. Normally, from the time that you select a feed additive, you are looking for a mechanism of action that you can demonstrate in vitro that is very clear. But what happens when you go to the animal is that it's a lot more complex than that. And what you find is that there is normally some core effects that normally align with those in vitro effects, but there are many other effects that are happening in that complex environment, for example, of the gut of the animal or the system in general of the animal. So you find, for example, products that have a very specific effect on nutrient digestion that can have effects that go, for example, in terms of fermentation, in the intestine, or effects that can go in terms of immune activation in the intestine, or sometimes effects that can go all the way to metabolic effects in the whole animal. So what we're saying is it's good to think about the effects of additives as context dependent, where there are some primary effects and there are some secondary effects, some of which will interact with what's happening in the environment.
Yeah, that's very true, and it's something that we can't uh, forget, or like we have to be mindful of that. And in regards to some of those factors affecting the efficacy or how that feed additive is working, you already mentioned a little bit of it, but what are some of the most critical physiological and environmental factors that might influence the performance of that feed additives in vivo?
Yes, it depends a little bit on the category of product, but basically there are a few main categories of factors that interact with the feed additive. So the first one is the level of challenge. And when we say the level of challenge, we're talking mainly about bacterial, viral challenges that the animal is under. And it could be in the intestine, but it could also be not necessarily in the intestine, like in the lungs or in other parts of the body. And that level of challenge affects quite a bit the efficacy, for example, of products that are targeting immune modulation or microbial modulation in the gut. So the effect of those products will really heavily depend on the level of challenge the animal is in. A second category that we find is very important is the level of stress the animal is under. So it may be that the microbial challenge is not very high, but there is heat stress, or there are mycotoxins, or there is cold, or there is high density. That level of stress will create pressure in all the body in terms of the metabolism, in terms of oxidative stress, in terms of the interactions between the immune function and metabolism, that will affect heavily the effect of additives that are actually putting a little bit of pressure, for example, on oxidative stress in the body in some conditions. So understanding those interactions is very important. And then the last one that is very important is the diet formulation and the balance of nutrients that the animal has, right? So we find that sometimes additives that have metabolic effects would have interactions, for example, with the level of fat in the diet, or the level of amino acids in the diet, or the balance of amino acids. So those interactions are very dependent on the type of additive and the effects it has on nutrient balance, but they tend to be very important in general.
Okay. Yeah, it makes a lot of sense. And like continuing on this line where we can have those different interactions that might be hindering the effect of the additive, of course, it's very dependent, as you said, on the type of feed additive and what you're looking for in terms of what it's doing on the animal. But have you come across cases where the same additive produced different results depending on the production context, perhaps enhancing performance in one setting, but showing minimal or even negative effects in other contexts?
Yes, and the truth is, like, for most feed additives, there will be situations where they work at their full potential, and there will be situations where they are not working at their full potential, or even some specific situations when they are actually slightly negative versus the, let's say, the baseline of production. Uh, I mean, we have many different examples, but I think what I can tell you is generally companies and professionals working with selling products have a good sense of where the product works best. They have hypotheses. Sometimes companies don't do enough work to understand the situations where the effects of the product can be potentially negative. So I think for companies, it's very important to actually do research in understanding both sides of the coin to be able to guide their technical service people better and provide them with the information they need to make decisions in the field, right? So because in the field, you are going to face those situations no matter what, right? So, and it's better to have enough information to make a good decision than just finding that out by the results that are not showing in some particular production systems.
Yeah. Yeah, that is very true and key, I think. Like you have to, as you say, know the whole picture and know how to anticipate or know what might be happening so you can also troubleshoot, right? Or understand why you might be seeing certain effects or not and what might be happening there. So that's very true. Um, and in terms of that, how can, for example, molecular tools like gene expression analysis help us better understand these context-dependent interactions? And what are the implications in terms of product design and evaluation with the use of some of these tools?
Yeah, so the traditional approach to product development on feed additives was to use or to heavily rely on performance trials and then select a few biomarkers that you are measuring that will validate if the effect is doing what it's the product is doing what it's supposed to be doing. Nowadays, we are using tools that can measure the broad array of effects of that the product can have in the animal. So, for example, in terms of immune function and oxidative balance and nutrient metabolism, we can get a very, very broad array of how the product is affecting the animal. We do that specifically using gene expression. It's called transcriptomics. There are other approaches. Some companies will be using proteomics or metabolomics or microbiome data to make some of those decisions. We like transcriptomics because it has a direct connection with animal function, and it helps us to understand those effects at a very specific point in time between two different populations. So it could be a control population versus a population with the additive. And we can actually measure the effects in different parts of the body, in different tissues. For example, we would be able to measure the effect in the intestine versus the effect that it potentially has in the liver. We like the liver a lot because it gives us a good picture of what's happening kind of systemically with metabolism, but also with immune function. But also, depending on the product, we can look, for example, of what's happening in the muscle, how that's affecting muscle deposition, etc. The way companies are using these kind of technologies is in different points in their new product development cycle. As I said, it could be from the very early stage to understand a problem and come up with a solution, compare different candidates that they want to develop. A lot of work is done also on optimization of the candidates to really understand what the optimal dose is, which formulation is better than other, if it works better in this diet or that other diet, etc. And then lastly, to have a good set of data to come to the market with and use it strategically to support the product. So that's basically how it's working at the moment.
Okay. Yeah, it's quite an interesting use of those tools, and I think they're here to stay, right? And they're really showing us what the effects are or how your feed additive is really working. So yeah, it's very interesting and definitely something to keep reading on and understanding. It's very important. And also, when looking into assessing the efficacy of these products, how important is it to separate core functions such as enzymatic or microbial actions from secondary effects related to the health status of the animal, for example, inflammation or nutrient partitioning? You mentioned a little bit of this in your previous answers when we started to talk, but can you expand a little on this?
Well, really, the advantage of thinking about the functions as core and secondary function is clarity, right? So I have a product, I have a phytase that breaks down phytic acid and releases phosphorus. Then there are many other secondary things that happen because of that in the animal. So there is higher absorption of phosphorus, there can be changes in absorption of calcium, there can be changes in the endogenous secretion of the animal in the intestine, there can be changes in the microbiota within the intestine, there can be changes in secondary metabolites that are produced and can have a metabolic effect in the body. When we understand core functions and secondary function better and kind of can map them, it helps to understand which one of those are actually important for performance, which ones of those are kind of nice to know but not so important for performance, and which one of those are very important in terms of interactions with the environment, right? So, for example, we have tested phytogenics that can be absorbed and can have an effect in the metabolism of the animal. Those effects are not normally measured unless you actually set up an experiment to measure them, but actually understanding those effects and how those effects can interact, for example, with how you formulate a diet, if it has more fat or less fat, if it has more sodium or less sodium, etc., can help you to optimize the effects of the product in the market, even though the main effect might not be that particular one, but it can help you to avoid limitations of the product when you are using it in practical conditions.
Okay, yeah, that makes a lot of sense. And you talked a little bit about the trials being run by companies and whatnot to test their feed additives. In your current or in your view, how do current trial designs and research protocols, do you think they capture enough variability to reflect real life production situations? Are traditional methods like meta-analysis or single condition studies enough to get a good grasp on this, or do you think things should be looked at from a different perspective or through different methods?
Well, I think it has been a journey for the whole industry to improve the overall view of how to perform animal trials and how to use the information, right? So actually from going to trials that will maybe cut and paste always the same trials and just you learn how to do the trial to show the effect of the product, and then you try to go to that with the market, and then people don't like it because it doesn't reflect their conditions. Then there was a process for companies to start kind of doing better trials regionally, closer to their customers, with input from the customer, with the regional technical teams that are closer to the real questions that are being asked in the field for application. And then there has been a lot of effort to put together meta-analysis using that information. I think there are two things. Like the first one is meta-analysis only work to understand the limitations and the opportunities with a product if you have a lot of data in a broad array of conditions. And one of the limitations that we see is that sometimes companies tend to do the kind of trials that will show positive results in general. There is always a bias as a person. We tend to do trials that show a positive result because I can use that in the market. But that's not always the best approach, right? So actually, you actually need to do the whole spectrum of what you plan to use the product, from the very bad to the very good, and use all the data. The other limitation is that you cannot rely only on performance, but you cannot rely on a specific biomarkers either, because that selection of biomarkers bias what you are looking for and what you're going to find. So if there are effects that are outside the biomarker you are measuring, you are lost, right? So you don't know what's happening. So really what we are seeing is a progression towards being able to use this kind of tools that encompass everything that's happening in the animal that is important So you can actually get a full view of all the changes that are happening. And when you start compiling more and more data using the same methodology, you can actually get a very, very good view of the effect of the product in a quantitative way. Actually, this is actually the core effect of the product. These effects, we see them in some conditions, we don't see them in other conditions, and it gives a lot of clarity for the use of the product down the line. But it's a progression, right? So these technologies are only maturing for this kind of applications and will continue maturing to the point that people will be able to use them in the field, but we are not there yet.
Yeah, yeah, for sure. And it's important to draw that point of like being able to see the whole picture and understand that variability and those changes in different scenarios. It's important for the success of these products, right? Not only communicating when the product itself shows positive effects. We need to see the whole picture if we want to improve and if the whole sector wants to improve as well, right?
Exactly. Because I mean, it's obviously we want to help our companies, our customers to develop better products and to sell their products. But at the end of the day, is to be able to create real value in the field for producers and for consumers, right? So uh, instead of rely only on marketing or literature information to make decisions, we need to move towards using more data-driven decisions that can actually deliver quantifiable value in the field for producers and for consumers.
Yeah, yeah, that is very true. And continuing on that line of thought, so how instead of treating performance variability as a drawback, how can a better understanding of the context-related effects become a strategic advantage in the way additives are formulated, positioned, or applied? We already touched on this a bit, but do you have any more thoughts on it?
Yeah, so basically, I mean, like if you look at the point of view of suppliers of additives, investment in understanding this variability is completely a strategic advantage. Uh, so kind of breaking the paradigm of developing products where every trial is perfect to show the thing that I want to show, but without understanding what happens in other situations. Like those companies that are actually making investments in understanding products in many different conditions with in-depth technologies are really building up the foundation to to be winners in the market, especially for companies that have very strong portfolios. If it's a company that has a very broad portfolio, understanding what each product can do or cannot do in each situation is a very strong advantage because actually I can use that information to position the product in different markets in a way that is going to deliver value and that will bring the whole company up. From the point of view of producers, I think what needs to happen is, okay, variability is a reality in the field. There needs to be a lot more collaboration, that is direct collaboration between the producers and the suppliers to actually demand those data and demand a better understanding of the product in different situations that apply to the conditions of the customer.
Mhm,
Uh, and we'll see like the probably the largest companies and the companies that are more innovative will be the ones that actually are going to move faster to do better research in the field to be able to understand better what are products actually doing in specific production conditions, right? So that
mhm.
part is still nascent, it's still early, but we'll see a lot of pull from companies that are very innovative, that are actually very interested in using this kind of technologies to go to a field and understand what is happening in the specific conditions of my production system.
Yeah. Yeah, that's very true. And in that sense, from a communication standpoint, how can nutritionists or technical teams in these companies explain some of that contextual performance differences to producers without undermining the confidence in the product?
Yeah, I think the key of that is clarity and simplicity, right? In R&D, scientists tend to like complexity because that's what we're trying to understand, and is part of life. That complexity of the animal system is necessary. But when you go to the market, when you go to talk to a nutritionist who's very busy, all that knowledge needs to be compiled into a very simple message. And the way that companies can do that, kind of navigate between that complexity of the real life and the simplicity that need to deliver in terms of message, is to use the information to target and position the products better for the applications and the conditions where they can deliver the most value. And optimize the product or use different products within the portfolio for conditions where those products cannot deliver the most value. And in each one of those situations, understanding the levers or the elements that they need to take into account to optimize the performance of the product. It can be very simple, but it needs to rely on a very strong foundation based on data.
Yeah, for sure. So yeah, it doesn't mean that all of the research behind it is not complex, but you have to be able to translate it in a simple way so that your message is clear and also very fine-tuned to the audience you're sharing that message with, right? Because at the end of the day, you want it to have impact and to really drive that point through. So that's very true. And with the rise of precision farming and real-time monitoring, this type of new tools, do you see a shift towards additive application becoming more dynamic and responsive, perhaps even adjusting to environmental or physiological changes like in real time? Do you see that happening?
I think that's going to happen, but it will depend on the development of some particular parts of the technology, and I'll explain you what I mean. So basically, we have seen a lot of development of sensors and digital tools and data collection, mainly in terms of environment in the farm, and in terms of, let's say, management of the operation, right? That has a lot of potential. To this point, it has helped to actually correct problems quickly, to be able to detect if a fan is off or if animals are not eating, or the problems that you need to correct very quickly in the farm. Now, to really be able to do precision utilization of feed additives, you need to get a better understanding of what's happening inside the animals. And that is one part that is not measured yet. So most of the nutritionists around the world are making decisions based on FCR data, ingredient quality data, prices, and the feedback that they are getting from the production people, from the veterinarians. But it's not being, or it's not having enough feedback of what's happening inside the animals. I think what's going to change in the next decade or two is that these technologies to be able to collect better information of what's happening to the animals, mainly on a subclinical basis, like if there is a subclinical challenge or if there is a nutrient imbalance or those kind of things, will be able to inform a lot better how to use additives. In the meantime, and that's something that kind of the most advanced nutritionists are already doing, is using the information that they are getting kind of more real time to make decisions in terms of additive use, but maybe in a little bit of a macro way, kind of more which feed additives I use, for example, in the summer versus the winter, or in some farms that are having more particular enteric challenges, or with some diets that have a low quality of some ingredients. I mean, they are doing that every day. The more data they can collect in real time, the better decisions they can make for the next batches of feed. But there's gonna be a point, I believe, where that closing the loop of the information and understanding what's happening inside the animal is really gonna make help us to get to precision nutrition in a way that we can not only use only the feed additives that are adding value in that particular situation, but also do changes in formulation that can adapt to that particular situation to maximize the potential of the animal or reaching the potential of the animal.
Yeah. Yeah, it has a great potential if you're able to close that loop and you have that like constant presence of the nutritionist being able to assess all that data and taking those real-time decisions. It has a lot of value if we can get there. So it'll be interesting to see how the industry moves towards that and how producers also become more open to it, right? And to using these new technologies for sure. And to finalize on that point and looking ahead, how do you see these types of tools and AI modeling? You talked about the integration of omics technologies, also microbiome profiling. How can these tools contribute to a more precise and context-aware approach when it comes to the use of feed additives in diverse production landscapes? What would your final thoughts be on this and looking ahead?
Yeah, I think the way we need to think about it for the future is there is going to be large data platforms that are going to bring together different sources of data. And they're going to bring together data from the feed ingredients and from the logistics, from the environment in the farm, from the actual flows of material and animals in the farms, together with this kind of data that is biological data from the animals, both in terms of inside the animal, but also things like pathogens that are present in the operations and other sources of biological data that we can put together. Obviously, for that to become true, there needs to be a lot of developments in terms of the application of those technologies in the field. And that includes things like how easy it is to take a samples, to ship a samples, to how useful are the insights that I'm getting back. Can I connect those insights with a decision? Can I track those decisions on time and actually see a result in the field? I'm confident we're going to get there. In the meantime, we see that the feed additive companies are very interested in using this kind of data to deliver value to their customers. And they are doing that in two ways. One is kind of putting together a stronger R&D programs that are kind of going deeper and understanding what's happening with their products in the animals, and using that information to advise their customers and make better decisions and develop better products. But the other is they are very interested in actually using this kind of technologies to help producers use better the products that they are selling. And that is something that is in development and we see will probably be in the field in 1 or 2 years where you can actually use this kind of technologies to go to a field, take a sample, understand what the problems are, and be able to recommend a product and actually see if the product is working or not working. There are already some attempts of companies doing that, and I'm sure the whole field is going to develop a lot in the next few years. We have a lot of confidence that we can lead that field based on what we're seeing on R&D. So we're seeing really, really good insights based on the utilization of the products and what we see in connection to performance that we can replicate in the field, but it's a matter of developing the different parts of the technology.
Yeah, that's very true, and it's something to definitely look forward to and see how the industry develops towards that, but it's definitely very promising. So Luis, I would like to thank you on behalf of nutriNews International and our audience. This has been quite an insightful conversation. So thank you for helping us to better understand how context shapes feed additive performance and where the industry and the whole field is going. So that's been quite a wonderful talk, and we hope to have you back soon to share more interesting insights on this. So once again, thank you for your time and for all your knowledge sharing.
Excellent. Thank you for the invitation. It was a pleasure.
Thank you very much. And we want to thank all of our audience and hope to see you soon. Bye, everyone.